Okay, so we've looked at how to find vertical asymptotes. Now let's look at how we can find horizontal asymptotes. And there's a couple steps to this. First, we compare the leading terms of the numerator and the denominator. And the leading term means that the term with the greatest exponent on the variable. Okay, so I take the term with the highest exponent on my numerator, and we'll just call this, for case of just to be general, x to the n. We'll take the leading term of the highest power on the denominator, x to the m, and a and b are their coefficients. Okay? And I'm going to compare just the leading terms. And the reason I do that is that the leading terms in the long run is going to dominate the function. As x goes towards infinity, or x goes towards negative infinity, the leading term is going to dominate the function. It's going to have more of an influence on the shape of the function than any other part of the graph. Okay, so let me give you the rules here, and then we'll look at an example. So we'll look at the leading terms, and we compare their exponents. So if the exponent on the numerator is greater than the exponent on the denominator, then there's no horizontal asymptote. If the leading term, the power on the numerator is smaller than the power on the denominator, then the horizontal asymptote is y equals 0, or another way of saying the x-axis. And finally, if they're equal, if the power on the top is the same as the power on the bottom, then we actually take their coefficients. Then the asymptote the horizontal asymptote is y equals a over b. Okay. And let us look at an example of how this works. And so I'm going to look for the horizontal asymptote of a function f of x. We'll call this example 2, okay, is equal to 2x squared minus 3x plus 1 over 4x squared plus 2. Okay. And so again, what I want to do first is look at the leading terms, and those are the terms on the top and the bottom with the highest exponents. And so on the numerator, that's this term. On the denominator, that's this term, because they both have a power of 2, and that's the highest exponent on the numerator, and this is the highest exponent on the denominator. Okay, and let's just compare them. 2x squared over 4x squared. Okay? And in this case, n is 2, m is also 2. And so because n equals m, the power on the top and the power on the bottom is equal, then the horizontal asymptote is going to be the coefficient. See, this is the last rule right here. We look at the two coefficients. So the horizontal asymptote is going to be 2 over 4, or y equals 1/2. And that's going to be our horizontal asymptote. And you can also see too that if we just simplify this expression here using the two dominant terms, x squared is going to cancel on the top and the bottom, and that's just going to leave us with 2 over 4, or 1/2. And just to show you that this actually turns out to be the horizontal asymptote, let's put this again into the calculator. I'm going to type 2x squared minus 3x plus 1 all of that over 4x squared plus 2. And I'm going to graph that. And I'm actually gonna zoom in just a little bit because the graph is very small. So I'm gonna go to zoom in, and I'm gonna zoom in right at 0, 0. And I'm gonna draw this this graph. This is the complete picture of the graph. I'm just gonna draw it on the side here. This is 1, this is going to be 0.5. Now, this graph actually illustrates a very interesting example that if we go towards the right, okay, the graph actually heads down towards 0 and then bounces back up. But if we go towards the left, the graph actually goes closer and closer to 0.5. Okay? And so I'm just going to put this graph here. I'm going to go into my table, and you can see that as the x values gets closer and closer to negative infinity, the y values get closer and closer to 1/2. If I go towards the right side here, you can see that the graph actually bounces up. Okay, but that's okay. It doesn't, remember the definition of a horizontal asymptote, it doesn't have to be like that on both sides. It just needs to approach a number as I go towards negative infinity or positive infinity. It doesn't have to be both. So in this case, the graph is getting closer and closer to 0.5. The y values are getting closer and closer to 0.5 as the x value gets closer to negative infinity. So I can say that the horizontal asymptote is y equals 1/2. Okay, let's look at our example, another example here of finding horizontal asymptote. I have a function f of x is equal to x minus 3x squared divided by x plus 5. And once again, I'm going to look at the leading terms. Okay. And that's the terms with the highest exponent on the variable. So on the numerator here, I have a choice between x and negative 3x squared. And since this has a square on it, this is going to be my leading term. So I'm going to look at negative 3x squared. On the denominator, I have x plus 5, and x is going to be my leading term. Okay? And I compare the two exponents. Now the exponent on the top is bigger than the one on the bottom, so this is going to, what this means is that n is greater than m. Okay? So that means there's going to be no horizontal asymptote. Okay, because you see that as x gets bigger and bigger, the top is going to dominate the bottom. I mean, x squared is going to be a lot bigger than x. Okay? So it's not going to approach any number, it's just going to keep getting bigger and bigger. And let me show you this on the graph. We cleared out the old graph here. We get negative 3x squared divided by x. Let's graph it. And actually, I'm going to zoom out a little bit so we can see it better. And you can see that this is a straight line. It doesn't approach any particular value. As x gets bigger, y just goes straight down towards negative infinity. As x goes towards negative infinity, y just goes up on forever. So it doesn't approach any particular value or any particular line. So in this case, this has no horizontal asymptote. Okay. And in my last example here, I've got a function 2x over 5x squared minus x. And you can see the leading terms are 2x and 5x squared. And since the exponent on the bottom is bigger